Hi friends, in the last video we discussed about the 4 key steps for solving any deep learning problem. In this video we are going to build a data pipeline from the scratch. So to do that we need to first download the dataset. So let's look at how to download the dataset, or not exactly how to, but from where to download the dataset. There are two primary options that you can download. One is the competition official page from where you can download. You can probably download the JPEG images, that's what we would be using, and it should be around 30 GB. The total data set, if you in case you click this complete thing, is around 109 GB, right, which is a large number, and there's a very high chance that we may not need it till the end of the competition. So there is an alternative to this that I would strongly recommend you to download, which is in this particular discussion thread. Okay, so thanks to Chris for providing the data set. So he has given data set of different sizes starting from 128 JPEG images of size 128 to images of size 124 124 height and width, right? So which one to choose, it's up to you, but to start with I would say I would recommend to start with 256. That's what I started with. So when you download this dataset, there is one key difference from the train file that you find in the original dataset. We will find something called TF record, which we will be using for creating the validation set. There is a bit of story behind the TF record, how the TF record was created, which we will look in another video. It was again created by Chris, and if you are eager to learn about it, I would strongly recommend to go and read this amazing discussion forum called Triple Stratified Leak Free K-Fold CV. We'll provide the links in the description below. Okay, so this particular column that which we saw, just give me a minute, is not provided in the official data, right? This is a byproduct of Chris' excellent work on triple stratified data split. Okay, there is one more important thing. We can see that there are certain minus ones here. Okay, they represent that the image is a duplicate, which we can happily remove it. So these are going to help us in creating a training and validation split. So let's go back to our notebook we are working on. So what we saw earlier was this. So we created a training data loader, that is basically we batched a bunch of training images together, and we created a split for validation, and we also have a bunch of images for validation along with the targets, right? So what do we need is we need to create a pipeline which creates images in this particular shape, a tensor of shape 64, 3, 256, 256, and a tensor of shape 64, 1. So how to do that? So in order to do that, let's look at what do we have as part of the dataset that we have downloaded, right? So we have initialized few variables. Let's not worry much about it. Let's read the train.csv which I just showed you, and let's plot it. Let's visualize the contents of the data frame. So the most important part of this data frame for us right now is the image name and the target, and of course for validation we look at the TF record, but that's for another video. Yeah, that's a very simple thing, to be honest. You can just look at get train split and you will understand. So what we're going to do is we're also going to look at the images. What does the train folder consist of, right? As you can see, it consists of multiple images. The list file is a very simple function which calls this path.iter directory that gives a list of all the files in that particular folder. Let's just quickly look at what it does. Since I end up using this particular command most of the times while understanding the data, I just wrote a small function to do that. There's nothing fancy happening there, right? So now we have a data frame and we have a list of files. So what do we need? What we need to create right now? So we need to create something called a dataset, a PyTorch dataset. What is a dataset? Before we look at this code, let's understand what does a dataset take as an input and what does it output. Okay, so for doing that, we create an object of a dataset, which is like the live instance. And now once you create it, it becomes almost like a list of elements. So how do you index an element, index a list? You pass some value to it, and the value should be less than the length of the index and should be positive number starting from 0. The dataset also follows the same principles as a list. So what are we doing here? We are saying give me the first element of the train data set. So what we'll do is we'll create it again. I made some changes in the earlier code. Okay, so it returns a tuple containing image, a JPEG image, and a tensor. So what is the first element of that? You can easily access it by doing this. And the second element is the target that we are looking at, right? So now we know what the dataset takes input as and what is the output of that. And if you look at it from a very high level, it is like a simple list which consists, each element of the list consists the data that we have in a particular format, right? So whenever we pass an index to the list, or in this case the dataset, it returns you the element at that particular location. Now let's try to understand what happens when you actually index, right? PyTorch internally calls you this particular function called getItem. Okay, so this element that you pass here is passed as the index variable. Okay, so what do we do? So we pass the index to the df.ilog. What it means is, let's quickly try it. Okay, if I want to access the first element, I say df.ilog of 0. Okay, this returns the first element of the data frame. Okay, once I get the first element of the data frame, I am pulling the image name attribute from that. Once I get this attribute, I create a path to find that particular image. And how do we do that? We use the formatted string. I think it's available from Python 3.6, and I really love to use this. I find it very comfortable. So all you have to do is you can use a variable embedded in a string. Okay, so we are creating a path. So the IAM path here contains this particular location or wherever our data is residing, and we take the image name given the index. So if you give an index of 0, we take the image name from that particular index and pass the path, create the path here, right? So all this contains this, a path similar to this. Okay, and which path it is based on the index that you pass to the get item, which ideally is the dataset index. Okay, so once you create the path, all you have to do is you have to open the image, right? So for that we use a library called PIL. Okay, from PIL you import the image class, and from that you pass the path to that and you get image. So now the image would look something similar to this. What is this transforms? It's a bunch of functions that converts the given image into the way PyTorch expects it. Okay, so right now to show you what exactly happens, I did not pass any transformations here. So if you don't pass any transformations here, what happens is these two, so basically this 2 lines of code does not get executed. Okay, and what are we doing here? We are saying if the data set contains is test as true, then just return the image, don't execute anything after this. What does it mean? For the test data set, particularly in the Kaggle completion or in real world, we will not have the target variable, right? So we just want to return the image and not the target. Okay, so now this is what happens in the dataset class. The other 2 functions, one is your initializer. You pass any variables, or you want to open some file. For example, the data frame, we are opening it outside itself. If you want to open it inside, you can do all those things here. And another important function that you don't want to forget, without which also the data set works but the next step of data loader will not work, is you have to tell what is the length of the data set. Okay, in order to do that, you just let's say if there is a list of elements, list of file names you pass, then you will say length of self dot that list files. Okay, in this case we have a data frame, so we say the data frame dot shape of 0, that tells you how many rows you have in the data frame. So that becomes the length of it. So the PyTorch dataset has 3 important functions that you have to do. One is init, which is not mandatory, but if you need any initialization, then you end up passing to that. So most of the datasets would end up having the initialization parameters or initial init function. Okay. The second one is the get item, which is the key which takes in an index. Okay, and for most of the use cases it returns the image and a target variable. In case of NLP, you would end up returning a text in a particular format, probably we convert it into tensors and then pass it on, and a target variable. And the next important thing is the length, which all it does is it tells how many elements the particular dataset can carry. Okay, so this is good enough, but PyTorch still doesn't understand a particular image. If you pass this to an algorithm, it throws an error. You need to convert this into a tensor. Okay, so to convert that into a tensor, we are using a function called toTensor. All it does is actually we can take a look at that code also. I'm not sure if it would be very easy to understand, but let's take a quick look. Okay, I'm sure it's not simple enough, or they are ending up calling another function called image to tensor, and we have to look where image to tensor is coming from. So let's not really worry about it. So let me explain you what a toTensor does. You can not use toTensor and you can write your own function, but it's always a good idea to use some pre-built functionality so that you know that you're not doing something wrong. So what toTensor does is the image, if you look at it, right, let's store this as image variable, and then let's say image.max. I hope it works. It's a PIL format, so okay, it doesn't work. So let's make this as a numpy array. Array. Right now we can say image.max and image.mini. Okay, you can see the values are between 42 and 255, and basically the values mostly will be between 0 and 255. Okay, so we don't, when we pass it to PyTorch, we want it to be between 0 and 1. Okay, that's one thing. And when we use transfer learning with the pre-trained weights, that model is trained with data that are normalized with a certain mean and standard deviation. So we also need to normalize that. If you do not understand why we normalize it, it's a common practice. Let's not dig deeper into it at this point of time. Let's go with the flow of it. So what we do, so this toTensor method, where did it go? Okay, the toTensor method that we find here is responsible for converting this numpy array or PIL image in nature. It's not a numpy array, it's a PIL image, to a tensor, and also converts these values from 0 to 1. So what we will do is, to understand this, let's do step by step. Okay, so first let's not pass this normalized parameter and let's see what happens. Okay, let's pass the simple transforms and let's just take the image. Okay, and then let's see dot minimum and maximum. As you can see, the value has changed from 0 to 1. Okay, now what we will do is we will pass in the normalization also to the toTensor. That means basically we're telling convert the PIL image into a tensor and then normalize the tensor, which is a standard practice before passing the data through a pre-trained ImageNet model. Normalization is a standard practice, but the ImageNet stats you would end up using if you're using ImageNet weights. If you're using some other weights, then you have to calculate the mean and standard deviation of your dataset. This is a trick to make the training smoother. We'll also look into the other concepts like batch normalization, which helps in intermediate, but let's not get into that. So what we'll do is let's do this, and now let's just take a copy of it and just run it again. Okay, now you can see that the data has changed So now the data is being normalized. Okay, so this is one important step that happens, and this is a miniature. So I did not explain you what is A dot, right? A is the Argumentations Library. Okay, what is Argumentations Library? It is an amazing library used for data augmentations, and it is very popular both in the industry as well as the Kaggle competition. It has a huge number of augmentation that you can apply. So if you see here the helper code, the get augmentation method has got a lot of data augmentation that happens, right? To make life simple for us at this point, we did not include it, but it's quite simple, and we will look at augmentation, how it affects when you have to increase your augmentation, when you have to decrease your augmentation in another video. So here we are not using augmentation because we are just looking at how to create a data pipeline. When training, it makes sense to use augmentation. So just to demonstrate it to you, I have removed the augmentation to create the transformation pipeline. Look simple for the demonstration purpose. Okay, once we have data, now what do we have? We have a data set, okay, which can take in an index and return an image and a target value. Okay, but what do we need? We need a batch of images and batch of targets as shown here. This is what we need, right? So for this, what do we need? We need to use a data loader. What does data loader do? It passes in multiple indexes. Let's say, for example, when you say shuffle equal to false, okay, and when you actually when you ask it for a batch, if the batch size is 64, it passes indexes of value 0 till 24. That means it calls the data set with 0 ones, 1, 2, 3, 4 till 64, and it gets all these values, all this tensor, image tensor and the target tensor, and then it combines it together to form one tensor. Okay, that's what the data loader does. Why don't we do it by ourselves? We can do a simple data loader by ourselves, but the PyTorch data loader comes with a lot of things that lets us shuffle things, and which helps us to do parallelization. So most of the modern computers have multiple cores to it. So just by increasing the number of works, it makes your data pipeline faster. So what are we doing here to create the data loader? We are passing the data set that we created here, and we are passing a batch size. The batch size is what the 64 is, and we change the batch size depending on the computer, the GPU memory you have. The higher the GPU memory you have, the higher batch size, or the image size also plays a very important role. Let's say you end up using 1024, then hardly you'd be able to use 1 or 2 images in a particular GPU. So smaller GPU, smaller images actually helps you to iterate faster. When you have larger images, we end up getting other problems with the batch normalization, which we'll discuss later. In the advanced topics, we'll discuss. Okay, and we say shuffle is equal to true. While training, we don't want our algorithm to understand the order of it, right? So we generally shuffle the data. So instead of passing the indexes from 0 to 64, it can pass any index value starting from 0 till the maximum of the length of the data set. So what is that in this case? We have already created a data set, right? So let's look at it. We can just say length of data set. So what does our data loader do? Data loader passes an index value starting from 0 till 33,126 number. It can pass value between these numbers, right? When you say shuffle is equal to false, it takes a random numbers between this range, 64 numbers, and it gets the corresponding data set element for each of this, and then it sticks it together. So that's all the data loader does, right? Probably in a future video we can also see how to build a data loader from scratch rather than using PyTorch. Though for a toy example, it is a good idea to build your own data loader to understand what is exactly happening. But in production or when you're experimenting, PyTorch data loader gives a lot of additional capabilities which you will miss if you write your own. So once we get a data loader, we build this completely from scratch, and I hope the next line works. So we pulled in a batch of elements from the data loader. Now we have a training pipeline which can give us batch of images. The batch in this case is 64 and a batch of target. Okay, so in the next video we will look at the get model, and the coming videos will look at how did we create the train val split. Probably we'll look at in first is train val, and the second one is we'll look at the get model, and at last we will look at the fit. So by end of these 3 videos, you will be able to train the complete code. Okay. Thank you guys. If you like this video, hit the like button and subscribe. And if you do not understand anything, please comment in the YouTube section. Thank you guys. Bye bye.